By now, you know how to find the length or the distance around a circle. We use the formula C equals pi d, where C represents the circumference and d is the diameter of a circle. You also know how to find the area of a circle by using the formula area equals pi r squared, where r is the radius of the circle. But how do you find the length of the arc that is created by this 40-degree central angle? Or how do you find the area of the orange-colored sector in this example? Well, in this lesson, we're going to learn how to do both. Notice this is a picture of an aerial picture of some irrigated farmland. And you'll notice that this farmland is in the shape of a circle with some sectors that are very easily identified. And you notice one that I've highlighted in particular in red. The question that I want to pose is, why would the farmer be interested in finding the area of the sectors in this irrigated section of land? If you think about it for a moment, you'd probably say, well, he'd need to know the area of those sectors, especially if he plants different crops in each sector. He'd need to know how much seed he would need to buy and how much fertilizer he would need to buy. So it's a very practical problem that we're going to learn how to solve. But before we move to that, I want to remind you of something that you've learned in the past. Suppose a movie runs 108 minutes and you only watch 2/3 of the movie. The question is, how many minutes of the movie did you watch? How do we find the answer to that question? Well, we remember that 2/3 of 108 has a very specific meaning, where the fraction 2/3 is the fraction of the movie that you watched. 108 is the length of the movie. And if we want to find the number of minutes that is represented by the fraction 2/3, then we multiply the fraction 2/3 times 108. And when we do that, we multiply the 2 times the 108, and that will be over 3. So 2 times 108 is 216. We'll divide by 3, and that gives us 72 minutes. So 72 is 2/3 of 108. What fraction of the movie is 72 minutes? It's 2/3. 2/3 of the movie is 72 minutes. We're going to use this concept as we find the lengths of arcs, portions of circles, and areas of sectors. So, let's look at the definition of an arc, or the arc length. The arc length is simply a piece of the circumference of a circle. An arc is a piece of a circle. An arc length is a piece of the circumference, which is the distance around. And we find that arc length by this formula. The formula is x over 360 times 2 pi r, or pi d, where the fraction of the circle is represented by the fraction x over 360. X is the number of degrees of the central angle, and 2 pi r, or pi d, is the length of the circumference. 2 pi r or pi d can be interchanged in this formula. So let's use this formula to solve the problem in example 1. We're to find the length of arc EF. So we're wanting to find the length of the arc using this formula, the arc EF. Well, notice that the central angle is 120. So that'll be x, and so we'll put 120 over 360. Then we'll multiply that times pi d. Well, the diameter d is twice the radius. The radius in this case is 6, so the diameter is 12. So now let's just do our arithmetic. Well, 120 over 360 simplifies to 1/3. So 1/3 times 12 pi. Well, 1/3 of 12, 12 divided by 3 is 4. So the length of the arc is 4 pi. We'll leave our answer in that form, 4 pi, although if we wanted an approximation that means maybe a little bit more to us, we would multiply 4 times 3.14, since pi is approximately 3.14. Let's look at another example. We are to find the length of arc LM. So we'll use the formula that we've already learned, where the central angle is 60. Now we get 60 by subtracting 300 from 360. So using the formula, x over 360 times pi d, we'll use the central angle of 60 over 360 times 6 pi. Since the radius is 3, the diameter would be 6. Now let's just simplify this expression. Well, 60 over 360 simplifies to 1 over 6. So 1/6 times 6 pi, 1/6 of 6 is simply 1. So 1 pi is equal to pi, and the length of arc LM is going to be represented simply as pi, or approximately 3.14.